Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over another problem in which you can use conversion factors to help you solve the problem and get your answer. So let's get into this. So in this problem you're given a pycnometer, and a pycnometer is some vessel or device that's used to find the the density of liquids. And so in this pycnometer, we're given that it weighs 25.60 grams when it's empty and 35.55 grams when it is filled with water at 20 degrees Celsius. When 10.20 grams of lead is placed in the pycnometer, and the pycnometer is then again filled with water, the rest of it is filled with water at 25 degrees Celsius, the total mass is 44.83 grams total, right? So then the question is, what is the density of the lead in grams per centimeter cubed? Okay, so we're given, in addition to this, the density of water at 20 degrees. So we're given the density of water. And so in this case, we're asked to find the density of lead. So it might help us to always keep in mind or remind ourselves, how do you find the density of anything, right? So if you remember, density of anything is going to be equal to the mass of the substance divided by the volume. So if we know the mass of the substance and we know the volume of the substance, we just take the mass and divide it by the volume, and we get our answer. And then they want us to find grams per centimeter cubed. So as long as you then take the density and then convert it to the units that they want, then you're good. So can we do that here? If we keep this in mind, they want to know the density of the lead in the pycnometer. So we need to know the mass of the lead and we need to know the volume of the lead. Well, it just so happens that they give us the mass of the lead. So the mass of the lead is 10.20 grams. So now all we need to do is find the volume of the lead in the pycnometer. That's going to be a little bit more challenging because they don't give us that right away, but we can find out what that volume is. Now, here, we know that the pycnometer is filled with a certain amount of lead, so there's a certain amount of volume taken up by the lead, but then we fill it up with water. The rest of it is with water. So if we knew the total volume of the pycnometer and we knew the volume that was taken up by the water, then we could subtract the volume of the water from the total volume of the pycnometer, and whatever's left should be the volume that's taken up by the lead. And then we could use our density formula here to calculate the density. So can we do that? Yes, we can. Because we're told here that when the pycnometer is empty, it's 25.60 grams, right? But when we fill it up with just water, the mass then becomes 35.55 grams. So what we can do is we can subtract that and we get the mass of the water. The mass of the water that filled the entire pycnometer. Well, how is that going to help us? Well, they give us the density of the water at 20 degrees. So if we know the mass of the water that filled up the total volume of the pycnometer, then we can get the volume of the water there, which is going to be the same as the volume of the pycnometer itself. So let's go ahead and do that. So we're going to have to take 35.55 grams, and we're going to subtract out the mass of the empty pycnometer, 25.60 grams. And when we subtract that, we get 9.95 grams. And that's of the water. So now we can use the density to convert that to volume, and the volume of the water is going to be the volume of the pycnometer. And so we do that. So here, we're going to take this now, and then we're going to multiply by the conversion factor, 0.99, excuse me, 0.9982 grams per milliliter. So I have grams here, so the 0.9982 grams of water on the bottom and 1 milliliter of water on top. So grams cancels out, and when we calculate this, we get, give me a moment, 9.9679. 9.9679, and that's going to be milliliters of water. So now keeping in mind, we have to pay attention to sig figs. So this is a mixed batch. We're subtracting, we're multiplying, dividing. So how do we keep track of this? So we want to do the subtraction first. So whenever you add or subtract your measurements, the answer that you get should have the same number of decimal places as the least number of decimal places in your measurements. So this has 2 decimal places, this has 2 decimal places, so my answer should have 2 decimal places. And it does. So we're good. Now, in the multiplication and division, the rule is that my answer should have the same number of significant figures as the least number of significant figures used here. Now, here I have 3 significant figures, here I have 4, so I'm only allowed to keep 3 sig figs. So I have 1, 2, and 3. So the 6 is my last significant figure. But I'm going to keep the other digits because I need to use this in further calculations. And so I don't want to have a rounding error. So I'm going to keep the digits. You really just need to keep 1 extra digit. So I could keep the 7 and just drop the 9. No big deal. But I'm going to just keep them both. So you do you. Okay, so now I have the volume of the water that was in the empty pycnometer. So now I know the complete volume of the pycnometer is 9.9679 milliliters. Okay, so that's one part. Now all I need to do is find the volume of the water that was in with the lead. So I'm told here that I placed 10.20 grams of lead in the pycnometer, and the rest of it is filled up. So filled up with what? Water at 20 degrees Celsius. So I have the total mass of the water, the lead, and the pycnometer, which is 4483. If I could find the mass of the water, then I could use the density again to convert that to milliliters, which would give me the volume of the water occupying the pycnometer along with the lead. So I can do that because I can take the 44.83 grams, and this is the empty pycnometer, the lead, and the water. I know what the mass of the empty pycnometer is, so I can subtract that. That's 25.60, so I'm going to subtract that. 25.60 grams. And I know the mass of the lead that's in the pycnometer, 10.20 grams. So I can subtract that, 10.20 grams. And when I subtract both of those from the total, what's left over is the mass of the water that's occupying the volume that's there. And when I subtract, I get 903 grams, 9.03 grams. So that's the mass of the water that took up the rest of the volume after putting in the lead. So now that I have the mass of the water that was in the pycnometer with the lead, I can convert this to volume using, again, the density. So now I'm going to take this, multiply by the same conversion factor. So I have 1 milliliter of water, 0.9982 grams of water. Grams cancels out. And when I calculate that, I get 0.0462, 9.0462 milliliters of water. So this is the volume of water that I filled the empty pycnometer with. So this is the volume of the empty pycnometer. This is the volume of the water that was taken up by the water. Right? So this is the volume of the pycnometer that was taken up by the water along with the lead. So now I can subtract these two from each other, and the difference will be the volume taken up by the lead. So I take, oh, and by the way, again, when I do the subtraction here, so again, if I'm doing subtraction, my answer should have the same number of decimal places as the least number of decimal places in the measurements. So they all have 2 decimal places. So my answer has 2 decimal places. Good. And then here again, since I'm multiplying and dividing, my answer here should have the same number of sig figs as the least number of sig figs in what I'm multiplying and dividing, in the measurements that I'm multiplying and dividing. So here I have 3, here I have 4, so the sig figs is 3 again. So it's going to be 1, 2, 3, so 4. So 4 is the last sig figs in this measurement, but I'm going to keep the rest because I'm going to use that for further calculations. So now I'm going to subtract those two. So 9.9679 milliliters, and I have that there, minus 9.0462 milliliters. And when I subtract those two, I get 0.921616. 0.921616 milliliters. Let me double check that answer. 921616 milliliters. Okay. So this is the milliliters of lead. So that's what I just found here. Now, again, here when I am subtracting, the answer should have the same number of decimal places as the least number of decimal places. And so now here, even though I have extra digits, I underline these so I can remind myself what the last significant digit was, because I can't go any further than that. So this has 1, 2 decimal places. This has 1, 2 decimal places. So 2 is the smallest number. So that means that I can only keep up to 2 decimal places here. So this is the 2 is the last significant figure that I'm allowed. Now I can use this. And again, you can keep 1 extra digit. I'm going to keep the rest, but 1 is enough. So now I can do the density. I have the volume of lead. I have the mass of the lead. So now I can calculate density. So density is going to be equal to 10.20 grams divided by this volume, 0.921616 milliliters. And again, that's the last significant figure for the mass, and this 2 is the last significant figure for the volume. So now I divide, and when I divide, I get Let's see. 11.067. So I get 11.067 grams per milliliter. And 1 milliliter is the same as 1 centimeter cubed. So they want grams per centimeter cubed, but 1 milliliter is the same as 1 centimeter cubed. So then that becomes 11.067 grams per centimeter cubed. Now, as far as sig figs go, remember when you're multiplying and dividing, your answer should have the same number of sig figs as the least number of sig figs in the measurements that you're multiplying and dividing. So here I have 1, 2, 3, 4. I have 4 sig figs here, but because on the volume here, my last digit that I'm allowed to keep is the 2. I can't count those, so I have 1, 2. So I have 2 sig figs. Oops. Sorry about that. So since my smallest number of sig figs is 2, then I'm only allowed to keep 2 here. So 1, 2, drop the rest. So my final answer is 11 grams per centimeter cubed. And that's how you find the density of lead in your pycnometer. That's it for this video. I hope you enjoyed the video. If you learned a lot from this video, if this helped you in any way, then please like the video, share the video, hit that like button over there somewhere. Hit that, subscribe to my channel, hit the notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any question or problem that you need help with, or if you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.